my welcome to everyone on the call. We appreciate your time being here tonight. If you look in this picture, there's a really important person in this picture. Of course, they're all important, but in the back row, starting from the left, the third person from the left is Miss Adele Ratcliffe. She's in the red shirt. Adele is the manager of the IBAS program that funds this effort, and she's truly inspirational. If you ever get a chance to talk to Adele and hear her vision for the U.S. machine tool industry, you will be ready to run through a brick wall. She's terrific and is the true leader of this program, and we certainly appreciate IBAS and all of its support. It's important work that we're doing collectively here. Okay, so I want to talk tonight about the CNC machining training program and then a bit about the metrology program as well. As Joni said, the CNC machining training program has both an online and an in-person component. Metrology is online only for right now, but we have an in-person component planned in the future. For the online component, if you've not completed it already, it is no cost. It is self-paced. You can begin and end at your leisure, and you can break it up. And in total, it's about 6 hours. The only requirement is registration so that we know those who have joined the training. It's broken up into modules. The first one is an introduction to machining. This lets us begin speaking the language of machining if you're not familiar with machining as a discipline. But it moves quickly toward computer-aided manufacturing instruction. So in modern machining, we use computer numerical control for our machine tools. So we give it a series of instructions that it follows in order to produce the desired geometry from the starting material. And we call that CAM, or computer-aided manufacturing. So we need to have a solid model, and then we generate tool paths to follow in order to reveal the geometry that we want. So we talk about that, and then we introduce machining dynamics. So what is the role of vibration in selecting the machining parameters that go into the CAM software? Once we've done that, then we return to the CAM instruction to say, okay, those numbers that are there, like spindle speed and step down or axial depth and step over or radial depth of cut, they matter. And so once we've identified that they matter, we use this app that's distributed with the program called CAM Plus that enables you to simulate machining operations. You can see the force and vibration. You can hear the sound of the cut. So our intent here was to get as close to the machine as possible while you're at your laptop at home. We finish with an introduction to machining cost, which incorporates the topics that we've already covered, because ultimately, you need to turn a profit if you're going to stay in business. Once you've done the online component, that is your golden ticket. If you've ever watched American Idol, that's your golden ticket to the in-person component. And that's a 5-day training. It's intensive, but it's a lot of fun. We only do 10 participants in each session, so we can give you personal attention and instruction. Within those 5 days, I'll show you a bit more, but we end up machining the components for an oscillating piston air engine. You assemble your air engine and you leave with that functioning engine. For the metrology component, it's two parts, where first we introduce the measurements that you might see on a manufacturing shop floor. So everything from calipers to a scanning electron microscope. Once we've done that, then we understand that there's uncertainty associated with those measurement outputs. We can never perform a perfect measurement. And so we introduce the concept of measurement uncertainty and how that plays a role in using manufacturing measurements. Okay, so Joni showed you some numbers. We like to show these off. We're so proud of the program. We're so proud that you've joined. You can see that we've exceeded 2,200 participants. That number continues to grow. Our next milestone is 10,000. So we need you to help us spread the word. We want to eliminate the machine tool workforce challenges that exist in the US today. That is our mission. If we look at how the participants are grouped, we see 70% are current students and 30% are currently in industry. Within those students, the majority of those are at four-year institutions. We'd like to make that better. We've started our high school recruiting efforts in earnest, and we're looking for two-year community colleges to partner with to add this content to their existing programs, and then also offer these boot camps so we can have a national network. More about that later. So here we identified where our participants are located relative to the depots and production facilities for the U.S. military. You can see there's quite a bit of overlap, and we are looking to support those facilities as much as possible. And so that's a big part of what we're doing here. This shows a breakdown of where our students are located by institution. So we have high schools in yellow, community colleges in blue, and the universities in black. And we see the distribution is similar, just right now we have more of the university participants. We'd like to grow those other numbers. Here's where our industrial participants are located. Not surprisingly, it's pretty much where our students are located. There's a more than coincidental overlap, I believe. So if I flip back between these two, you can see they're almost exactly the same. And so that's a good thing. We are educating students where we need them, but we're not educating enough. And so that's part of the mission here of ACE, is to add to those numbers. As it stands right now, Tennessee and North Carolina lead in terms of the number of participants who have joined the online training. I think much of that is because of our physical location, but we look to grow that in the Southeast and beyond. So the metrology program is just over a year old. We started it in March of last year, and we're closing in on 400 participants. Our breakdown is a little more heavily toward industry in this case, 42% from industry, 58% are students. But again, we see the students dominated by the four-year programs, and we're looking, however, to grow that into our two-year institutions and high schools. Ultimately, we see these as both value-added manufacturing operations. You machine components to add value because you're giving geometries and surface finishes that meet design requirements. Metrology is a value-added manufacturing operation because you quantify and qualify the parts that you've produced regardless of the manufacturing operation. Again, the leading states here are Tennessee and North Carolina, but certainly we're looking to grow those numbers. Okay, so there's probably more of you on the call who have done the online training than have done the in-person training. So let me talk a bit about what that in-person component looks like. As I mentioned, it's 5 days. We go from about 8:30 to 4:30 each day, and we keep you running all day long. We split our time between the classroom and the laboratory. So we review the CAM. Fusion 360 is our learning platform. Although the training could be extended, I suppose, to any CNC software, but Fusion 360 is what we use during the week and online. We discuss CNC machining process flow. So how do you get from bar stock to a finished part? We machine and assemble components for the oscillating piston air engine that's shown here. And we also take time to illustrate the importance of machining dynamics. We do a tap test, where you use an instrumented hammer to tap the cutting tool and an accelerometer to measure the vibration response. With that information, we're able to select machining conditions that avoid chatter, which is a self-excited vibration that produces bad surface finish and large forces, and it's something we want to avoid, but we want to avoid it without trial and error. We want to use our understanding of the physics of the machining process and give that information to you in a way that lets you leverage it in a career in manufacturing. So our oscillating piston air engine has 4 parts that the participants machine during the week. The first one is the base component. It's an aluminum component, and it's actually what was programmed during the online training. We then do the piston block, another aluminum component that guides the piston motion. And then we have an additively manufactured polymer block, which is the valve block. This particular part is well suited to AM because it has complicated internal passages that enable the airflow for the piston to come in and out due to the air pressure that's applied in the back. And then finally, we machine a wheel. This is a steel component, and so we get to talk about the difference between machining aluminum and steel and the polymer. So 3 different materials there. Finally, we machine the pistons for you in advance because that's a turning operation, and we don't do turning during the course, but we do let you drill the cross hole in that piston that's required for final assembly. We provide the hardware for assembly, and we let you assemble these air engines on your own. So here's what the week looks like. On Monday, we provide a review of machining to review the language that we learned in the online component. We introduce M and G codes. This is the programming language for machine tools. And then we have you machine the air engine base component, as I mentioned. Within an hour of arriving at the training, you are machining your first component. This is a hands-on do type course while we're learning best practices as we go along. On Tuesday, we review machining dynamics, the vibrations that matter during machining. And then we discuss how work holding is required, how we establish datums and use those when we generate our tool paths, and then we machine the piston block. On Wednesday, we review machining cost and machine that polymer valve block that we've printed for you in advance. On Thursday, we review metrology principles that I talked about. We machine the steel wheel and then get our first chance to assemble the air engines. On Friday, we review that CAM Plus simulation software and perform our on-machine tap testing and chatter example. So we intentionally select parameters from the tap test that will be stable and those that will be unstable or produce chatter. So you can see and hear the difference, and we pass parts around so you can see them. And we talk about how we use that information when we're generating our tool paths in the CAM software. We then have our assembly competition, which I'll show you. We allow you to machine a logo into the piston block and then complete our program evaluation. So I've got a couple videos here so you can get a sense of what the in-person training looks like. The first video I'll show you is how we set up the on-machine instruction. So we avoid having folks standing around and not being able to hear and getting bored. So at the machine, we have an instructor, we have an active participant, and then one observer. That is the participant that will run the machine next. Everyone else is working on their CAM software together, and we have an instructor in place there to help with that CAM toolpath planning. So we want to avoid you being in a situation where you look around and say, I don't know what to do. We have someone there to help you, so you'll know what to do and make it a meaningful learning experience. So this is what it looks like when we are carrying out the on-machine training. This is an actual participant machining a component. The instructor is in blue. It's our famous instructor, Emma Betters. She's wonderful. So you get personalized instruction at the machine. There's the one observer at the machine. She'll run the program next. Here are the other participants working on their CAM tool paths, and there's the CAM instructor. That's Jake Dvorak, again, just a wonderful instructor that's part of this program. In the picture below the video we just saw, you can see one of the logos. That's the ACE logo that you can machine onto your piston block. The next video you're going to see is our competition. So we have a head-to-head tournament-style competition where the fastest assembler advances. This is just like March Madness, only it'll be in June. So this will be June Madness. So we provide you with the hardware and the Allen wrenches that's required to assemble. Both start at the same time, and then you race to the end. At the end, your assembly is complete when the air engine runs, and so we have pressurized air available for you to run your piston air engine. At the top, you'll see the printed valve bodies. In the middle, on the right, that's where they're probing a valve body using the soft jaws that we provide to hold that particular part geometry while machining. See the CAM work on the bottom. And then here on the right, this is the air engine running. If assembled properly, it runs pretty fast. It's a lot of fun. So this summer, we'll have a number of boot camps. The ones I'll host at the University of Tennessee will be June 6th through 10th and June 20 through 24. Those are filling up quickly. So if you're interested, you'll need to contact Tyler Blevins, IACME man of all hats. He handles the logistics for getting these camps running. We're also going to offer 2 new sessions where we're going to do train the trainer sessions. These will be 2-day sessions where we will teach you to run these boot camps. We are currently working on a national network so that we can offer this training throughout the US without me needing to be there. So essentially we're replicating me with you, and I'm sure you'll be an improved version and you can take this training back with you. IACME is managing that entire process and doing a fantastic job, so Joni can point you in the right direction there.